It's Monday, April 6th, 2015. I'm Rim.
I'm Scott.
And this is Geeknights. Tonight, FPGAs and all those related things.
Let's do this.
Been a while since we've done a Monday show. It's just the weeks we kept missing happened to be weeks where we'd come back on a Tuesday, Thursday.
That's generally how things work. If you go away on a weekend, Monday's a bad day.
Yep.
Also, Monday's the day with the least ideas.
Well, the thing
so
is,
we're the most likely to bail on it.
We came up with this idea on the last show.
Sure.
And thank the gods, convention season is done for us until July with Kineticon.
Yeah, I mean, usually convention season is summer. Usually, right? That's
well,
when the biggest...
we always say usually. It was usually for us like 5 years ago.
But I'm saying conventions originally, historically, were all mostly in the summer. And the big ones still are. The Gen Cons, the San Diego Comic Cons, whatever.
Yep. But the big summer cons that we used to go to, we stopped going to.
Conventions are supposed to be in the summer. That's when kids aren't in school, so they can go.
Wait a minute. By that logic,
so they can go.
By that logic, I only want conventions that are during school.
Sure. But I'm just saying, if you're the convention runner, you want to get the most people to come. They're usually in summer. But all the other conventions, the ones we go to mostly, had to abandon summer to get away from the mega conventions that were in the summer, taking up all the peoples. So we end up going to like a bunch of spring conventions and winter conventions.
Yep.
Like PAX Prime is the very end of summer. PAX East is like the beginning of spring.
And then what made it worse?
They got pushed to the edges of the summer.
Because there are 4 PAXs and they're in different parts of the country or the world, they end up they can be clustered way outside of the norm of the convention circuit in the Northeast.
But this is fine by me because it means I don't have to do anything in summer except enjoy summer. I don't have to abandon some awesome summer weekend to go stay in a giant building somewhere.
But yeah, I'll keep it short because it's not gonna turn into the biking show. But today was the first day of the season. I biked to work.
Still too cold.
What the fuck? It's like 60 degrees.
Yeah, which means when you bike, it's like 45 degrees.
Scott, you're a little baby. I don't even know what to say.
All right, I'm
going
to shave your head, and then I'm going to send you biking.
Wear a hat. You got to wear a helmet anyway.
A hat is not good.
I mean, I biked to work today, and
there's no happy medium. Either your head is melting because you put a hat on.
Scott, my hat is not the factor. I was wearing shorts and a t-shirt. In fact, I was wearing a button shirt that I got hot and I unbuttoned.
Did the bridge not blow a mighty wind across you?
It did. But you know what? I was biking so hard, I was still hot.
Why are you biking so hard just
I
to
always
go to
bike.
work?
Scott, so this is what's awesome. I biked to work and back today, and I used Strava. Running hard all winter really paid off. My time not only didn't go down significantly over the winter, but my first commute home from work took 30 minutes, and historically, my best time ever was 26 minutes.
My commute is about 30 minutes.
My commute's 6.8 miles.
Mine's 5 miles.
Yeah, 5 miles, really?
Yeah.
It takes you. Oh, I guess you got that Astoria stuff.
Mm-hmm.
So can you do 6.8 miles in 26 minutes?
I don't bike hard. I just sort of mosey, and it takes me 30 minutes to do 5 miles. So
Yeah.
I don't know how fast I would go as if I was trying
I always bike
to damage my body
I
and
always
suffer
bike
in
hard.
pain.
See, I don't bike to damage levels. I bike to hard levels. I bike to how fast can I go without getting to the point where I cannot breathe fast enough to replenish oxygen.
I do not exert myself. I exert myself to the point at which, if I exerted any more, I would feel uncomfortable. I do not feel uncomfortable at any time
Do you
whatsoever.
still want to do that race? I don't think we should race.
What kind of race?
We were talking last year. We would do a race. We both leave at the same time. First one to the Sand and Rockaway.
Sure.
Take any route you want.
Sure.
You want to race? You want to do it?
Yeah, why not?
We should both GoPro it, giving commentary the whole way.
So this is the shortcut I'm taking, and I'm moseying along. Meanwhile, Rim pushed himself way hard, and he's on the bridge, and he's dying.
Dying? You mean winning?
And here's me catching up to Rim on the bridge, just sort of moseying, and I'm behind him, and I pushed him off the bridge. Now he can't win.
The thing is, we would not be on the bridge at the same time. You wouldn't be able to push me off.
Uh-huh.
My main strategy when there's danger is to run away faster than whoever it is who's trying to hurt me.
Mm-hmm. Oh, good. I'll just stay right behind you until you pass out, and then go to the beach.
Yeah, unlike my man Mitsuji, I think I can power through to the end.
That's what Mitsuji thought too.
Yeah, but he wasn't as powerful as I am, apparently.
Sure, okay.
So you got any news on this Tech Monday? Back from Anime Boston? Back from ZenkaiCon?
It's
back from PAX
sort
and PAX
of
and
a
PAX?
news. I don't know. It might actually be an old thing that was just recently, again, re-brought up on the internet. Or it might be new. I can't tell. But it's just kind of cool. Estonia, a country on the other side of the world. I'm sure this country has problems. I'm actually going to be honest and say I don't know a whole lot about Estonia. I know it's in Eastern Europe.
It is perhaps a member of the Baltic states, along with Latvia and Lithuania.
Yes, that is about all I know. But I know one more thing about Estonia now.
Super techie.
The whole Eastern Europe is pretty techie,
But
right?
Estonia
in a different way than we are.
particular and above other states is particularly techie at the government level.
Sure.
And has been for a long time.
So one thing Estonia offers, and it sounds awesome when you hear what it is, which it's less awesome in reality, is e-residency. So at first you're thinking, holy shit, I could be an Estonia resident, but digitally and not have to go there. And that is sort of true. But it's not as awesome as you would think.
But at the same time,
most punk kids out there, if they're like me when we were in our like Sealand thinking days,
Yep.
they're thinking, gonna renounce my U.S. citizenship. I'll be an Estonia e-resident. I'll live on the internet. Sovereign citizen, can't fuck with me. Right?
Yeah.
That's what the punk kids are thinking right now. But sorry, punk kids, that's not what this is.
see, sadly though, I knew the thing that this was because I already knew about this from Estonia, but because of what they're calling it, it's not entirely obvious that it's the same thing right away.
Right. So what this is you become an Estonia e-resident, you apply, and they give you like a card, and the card has some, digital keys in it, for, secure signatures, private public key deal. And you can use that card with those keys to legally sign documents like contracts in Estonia. So this is ridiculously useful if you want to conduct business in Estonia. Like, I'm a U.S. citizen, but I want to open up an Estonian business or open up a web store that sells things to Estonia or any sort of Estonian business deal. Maybe I got to
Now,
sign.
meanwhile, look at the U.S. You either scribble some ink on a dead tree,
Yep.
or you try to use PGP signatures that no one can figure out,
Mm-hmm.
or you have to use 100% Adobe workflow, and even then, it's not the same level of cryptographic trust.
No, not really. It's also trust Adobe and the government, right?
Yeah.
But yeah, if you want to do business in Estonia, you can get one of these things. And it's really freaking useful and cool and modern. And I don't know why every country doesn't have this.
Dude, the U.S.
because every country is not Estonia.
This should have appeared in the U.S. they're in the 90s.
But they banned exporting this encryption in the 90s. That's why
Because
they
it was a
wouldn't
weapon.
Sure.
Yeah.
Yeah.
The Zimmerman stuff.
Right.
Yeah, I've said this for easily 20 years now. The U.S., when you're born, instead of getting a piece of paper with a stamp printed
You shouldn't
relatively
need a
small
You shouldn't
number,
need a birth certificate, a driver's license, a social security card. You shouldn't need all these fucking
well,
cards.
I'm specifically Social Security.
Yeah, one government card, one key on there. That should do every single thing there is to do.
Every citizen, when they're born, should be given a private key. And basically, it's a thing that you can use to cryptographically, not for hiding things, not for encrypting things, but cryptographic signing. So
Yep.
you can prove who you are, and you can prove if you did something or not in an official capacity.
Yep. It just needs two factors. One, the card itself with the keys, but the
Yep.
keys are encrypted. So the second factor is the password to decrypt the key to do the signing.
This technology
Just like
has existed
SSH.
since the 80s, and the fact that other than in Estonia, it is not in common use for the things that it is best
For every
at.
human being on Earth?
Yeah, it's this solves
Guess what? There's plenty more keys than there will ever be human beings to ever exist.
this technology solves a ridiculous number of the real world problems that people in the industrialized world have been facing for 100 years.
And Estonia is deploying it. So good job, Estonia.
Yeah.
You are inching up on the list of countries to run away to should we need a country to run away to and the other ones don't cut it.
Yeah, the thing is, right now, top of that list is still Australia at this point and New Zealand.
They speak English there. That's a bonus.
Yep, it's super nice and warm.
Tropical coral reef. That's a bonus.
Not more racist than the U.S.
They have a PAX. That's a bonus.
They do have a PAX. Think about it. We can flee and still be going to PAX every year, and suddenly going to Japan, not that big a deal. You want to just go to Japan?
Hey, let's have a weekend trip to the hot springs. Basically
Yeah.
the same as a weekend trip to Florida.
Yeah. So, Australia is real high on my runaway list, but Estonia is surprisingly not. It's cold there relative to other places.
Sure.
I mean, it's latitude-wise, it's like at the top of Scotland. So yeah. Why do all the nice places have to be in the shitty places?
Because the warm places, while awesome and warm, are full of like disease. Because also nasty poison things live where it's warm.
Yeah, but also bad governments often.
Yes.
Which is not necessarily the fault of the places or the climate, but pretty much, you know what? Who you can blame for this?
Bananas.
The British.
Them too.
Yeah, the British and bananas, the bees.
Yep.
Blame the bees. Buzz, buzz.
What kind of news you got?
All right, so Hyundai, or Hyundai, if you're
car company.
American.
Mm-hmm.
You know, I don't want to get into like all the side societal stuff of self-driving cars, but I cannot stress this enough. This shit is moving way faster than you guys realize.
Yeah, it's like a lot of times there's new fancy technologies, and some of them actually happen, and some of them don't.
Like Amazon drones, like yeah, they're moving fast, but they're not ready yet.
Yeah, you're not gonna see. It's like, you know, we've seen flexible screens. Right? The kind you can roll around your finger for a long ass time.
Dude, I saw a laser projected keyboard that's virtual that you type on a desk with
like
from a
10
phone.
years ago.
More like 20 years ago.
Yeah, I've seen the flexible screens since at least 10, 15, 20 years ago. And
but self-driving
we don't have
cars,
them yet, but the self-driving car, which we only saw a few years ago,
they're already ready for prime time.
This is going to happen.
Like, not even going to happen. It did happen. The existing technology.
I would invest in self-driving car if there was a company where I could afford the shares that wasn't Google.
Might be Hyundai.
Well, Hyundai
but they're
is
doing
not
it through
exactly
Google.
A small company. That's
so I don't know how much. You know, I bet there's an ADR. I'll look
also
it up.
isn't
Anyway,
it Korean? That's
yeah.
not, yeah.
You'd have to invest through an ADR unless you're.
It's not.
That's how I bought all that Toyota stock.
Yeah, it's a pain in the ass.
No, it's not. Scottrade just has ADRs.
Anyway,
they're not special. They act the same as the regular stock. You don't need to do anything.
Continue.
So, the technology as it literally exists today, right now, is safer than humans at highway speeds. And it's already better.
Mm-hmm.
If we never advance this technology further, we would still be obligated from a moral standpoint to deploy it today because fewer people would die.
Yes, morally speaking, you should not be allowed to drive a car. A human being has no reason to ever drive a car in public. Only on like racetracks and other special events should a person be allowed to drive.
So
otherwise, you are simply risking death or risking murder.
So laws and all these things are just like not catching up. I mean, look, states are banning the sale of Teslas. They're not self-driving. They're just electric.
Yeah.
So Hyundai this year, 2015, is selling a car that you can just buy that has autopilot that you can just use.
But the whole point is that if a car is autopilot, I don't have to buy it. The whole point is that there would just be cars around, and I go outside, and one comes up to me, and I get in, and it takes
you say
me a while
that.
to
So
go.
here's the difference. That requires a broader infrastructure and all these other changes.
What changes does it need?
That technology isn't 100% there yet.
The technology of the car knows to come to get you.
Yeah, pick up, drop off, load balancing. Like, there's stuff, like, there's a lot of infrastructure and research still has to happen there. Forget the laws. Ignore laws.
Mm-hmm.
Just technology. The car picks me up, drops me off to school, and, like, I don't have to do anything is not there yet. But what Hyundai is selling is you can be in this car, this real car that will cost like $60K. Like, it's not that expensive for what it does.
That's more expensive than a BMW.
Yeah, it
At
is.
least, I mean, there are BMWs more than that, but
So
there are also
supposedly,
some less than that.
Here are the two features it'll have. If you're on a highway or freeway, you turn on autopilot, and you can just let go of the steering wheel and take your feet off the pedals and do whatever, and it'll just drive.
Alrighty.
It'll follow the road 100%. It'll brake. It'll do speed. It'll do everything.
I would get in it. I would let I'd have to see it first, right?
Yeah.
I'd let the guy test drive.
Now, you're not allowed. Here's the thing. Because of laws, like, you wouldn't be allowed to just, like, crawl into the back and go to sleep.
No. But I want it, like, if they had these for sale in the U.S., I would go there. I'd let the dealer take it out.
Yep.
I'd be like, you turn on the autopilot. And he lets it go. And if I see that I'm sitting in the passenger seat, if I see that I'm not dead,
Yep.
then I'll do it.
I would tell him to go with my phone live streaming back to me.
Oh, sure. Good idea. Yeah, okay.
But the other thing it'll do is it has a traffic jam mode. If you're in a traffic jam of any kind on any street,
you need to tell it or just do it?
you just be like, traffic jam. Then what it'll do, same thing, let go. And instead of highway stuff, what it'll do is it'll just basically follow the car in front of it and deal with shit.
But you got to keep your eye open for when the traffic jam's about to end.
I'm pretty sure it'll be like, traffic jam ending, or something. So this is a real car that you'll be able to buy this year.
In only Korea, because a Korean
No,
car?
U.S.
All right.
So yeah,
You want to buy one and split it?
kind of. Yeah, maybe.
You can pay for the parking spot.
I mean, but here's the problem, Scott.
I'll pay for the insurance.
For the price of this car, we could each buy a brand new Lotus Elise. And yeah.
Oh.
Yeah.
That's a shame.
But BMW is releasing something similar, likely either this year or next year. Google seems to be the one powering both of these cars, but that's just rumors.
I have money. I should buy a Lotus Elise.
Yeah. So
What am I going to do in the winter?
I can't die or not drive.
Not drive.
I cannot wait for this shit. Like, you do not understand. Because imagine this world, even if it only does it on freeways. Like, even if the technology was only that, of only freeway mode, like, it'll drive you to your exit and then get you off at the exit, and you have to drive to and from the freeway. That turns every freeway in America into a always running, the train comes exactly when you want it to, bullet train.
Mm-hmm.
All you have to do is drive to the train station.
Well, it's not a bullet train. A bullet train goes 500 miles an hour.
Yeah, but
this goes 5 times slower.
Yeah. So it'll be like a Acela.
6 times
It'll
slower.
be like an Acela that literally every entrance and exit ramp in the entire country is an Acela station. And the express trains go from the station you got on to the station you got off.
Except there's all this traffic.
Yeah, but
and accidents.
Yeah, well, but the car is probably better at dealing with those accidents than I am.
People might crash into you.
Yeah, but the thing is, they were going to crash into you anyway.
Sure.
Plus, I mean, trains kill people.
Sure. Not as many as cars.
Yeah, cars kill way more people than skiing.
Kill more people than anything.
Yeah. Actually, there's a scary side note. You know what kills more people in New York City than homicide right now?
Oh, drugs?
No, specifically just heroin overdoses.
Well, that's the drug that's going to kill you mostly.
Yeah, that I mean, meth will kill you, but in that long span of you're dead because of life choices.
Well, it's because the heroin's too strong, yo. They're not giving the same heroin they used to. Now they're giving the heroin that's like...
What is that? Is that your political party? The rent is too damn high. The heroin is too damn strong.
Right. If they would just dilute that shit, then it wouldn't kill people so instantly.
So, one more little news, because this is a rumor that just came out. LG apparently accidentally published a blog post early and then deleted it. And it appears that Apple has an 8K resolution iMac for this year.
This seems a bit ridiculous. Like,
that is 7680 by 4320.
It's hard to believe that this is real.
If that monitor is not 60 inches.
If it's not 4 monitors stuck together.
I mean, I'm kind of this seems to be legit. No, people are talking about this this leak is legit. So
April Fool's late.
I don't know. Let's keep an eye on it. It's amazing. I think you pointed out, we were talking about this before the show, how even if this isn't true, only Apple is doing this right. Apple is
yeah. All the other companies, usually, I make fun of Apple because a thing that they do is they'll copy other people's technology, make it better, obviously, and then come out with it, act like it's new, like they invented it. Like iPhone, it's like, dude, we had Palm Trios 7 years ago. Where have you been? Oh, but this one doesn't suck. Tablets, ViewSonic and Microsoft are making tablets 5-6 years. Where have you been?
Yeah.
Oh, yours doesn't suck. Right? Oh, we had virtual desktops on Linux and Unix in the 80s. What are you doing?
Yep.
Oh, actually, spaces are actually
remember
pretty
when
much
flat panels came out and suddenly everyone's got this 1080p monitor and I'm like, what the fuck? I had 1600 by whatever on my CRT.
Yeah.
But
everyone has
touchpads
touchpads on their laptops. Oh, this Apple one doesn't suck, right?
Yeah.
So, people had 4K displays, but it's Apple pretty much has run away with it. They are dominating it. They came out with the Retina before everyone else, and they're better than everyone else.
Yeah, they are.
And if this is true, they're not even letting Windows still can't really do 4K.
Yeah.
And Apple's oh, well, while we're ahead of you, let's run to 8K. Aha, you suck.
Yeah.
And the thing is, the hardware can do it. The video cards have DisplayPort. They can push it.
I mean, you know what it's like? It's like an Advance Wars where
Macs are mad weak compared to most Windows PCs that are any good. Why doesn't someone make these fucking monitors stand alone, Dell? Your 4K monitors are garbage.
Yeah, well, there's a lot of things that have to change. For
software,
example...
Yeah, Windows software. Why don't you update?
Apple can get away with a lot because the monitor is basically baked in with the computer.
Yes.
I mean, DVI can't push that. DVI can't even push 4K.
The new DVI can.
The new DVI, but
Yes.
don't you need the full like double cable too?
You don't
right?
need, no, you don't need the double cable with the
Really?
newer DVI. If you use the DisplayPort.
DisplayPort.
DisplayPort. If you have
Yeah,
the old,
I was talking like DVI.
No, but DisplayPort, if you have old DisplayPort 1.0, I guess, I think is the old version, the one you're using now.
You know
then
why I lost track
you
of
would
those
need,
formats?
You would need 2 cables for 4K. But if you had the new version, DisplayPort 2.0 or whatever version number it frickin' is, then you could use one DisplayPort cable for a 4K monitor.
You know why I lost track of all
8K,
that? 1920 by 1200 is basically the best you're going to do in Windows.
Pretty much. I mean, you could get a 2560 monitor, but it's going to be
I-
either a really big monitor or not. So it's not about the. It's like Windows can do the high resolutions. It's
Kind
just
of.
it only does them for a big monitor. If you have a small monitor with a high resolution with the increased pixel density,
Some things
you can't-
scale,
you
some
can't-
things don't.
You can't see anything because everything is so goddamn small.
Yep.
That's why like you'll get 2560 on like a 27-inch is fine, but Apple's doing like that on a 19-inch level right, or some shit. Everything's you're like, can I even read this text? Zoom, zoom, zoom.
So 8K approaches the resolution of that thing in wool.
Yeah,
Yeah.
yeah, kinda.
So we'll see what the deal is with this, but if it really is this year, I think that the moral of this year and last year has been wait for September 2015.
Yep.
Everything is happening in September 2015.
Apple 6, iPhone 6s.
Yep. Oh my god, if there is a smaller iPhone, you cannot understand how fast my Nexus 4 will just fall out of my pocket as I'm running toward an Apple store.
I think the rumor is they're going to make one that's the same as the iPhone 5 size.
I could deal with that at this point because remember, the phone I was thinking about getting was the Sony Xperia Z3 Compact. The Compact is about the same size as my Nexus 4. Knock it like I've given up. This is the smallest you're gonna get for a long
Yeah.
time.
I'm going to get the iPhone 7 mini in 2016.
Yeah, because that's gonna happen.
iPhone Nano.
What I am gonna get in September is whatever iPad Air they announced, probably.
The big iPad is too big.
Yeah, well, I don't know.
I'm just going to get a bigger iPad mini because the one I have ran out of space, even though it's perfectly fine, but I'll
See,
sell
already
the one I
though,
got.
here's the problem. I use my laptop primarily to do the kinds of things that are hard to do on a tablet, but when I'm on an airplane, I use my laptop primarily to do the things that I should be doing on a tablet.
Once
So
I got the
kinda need a
iPad, I
laptop and a
basically
tablet.
almost never use the laptop. Almost never.
Yeah, I
It's
do.
like-
I do a lot of typing words when I'm away.
Yeah, I don't type that many words at once.
But
so
then
I
you know
can
what Emily
type-
does? She just carries around like a little Bluetooth keyboard.
You can also do that.
Yeah. So it's pretty much September. I'm either getting a Surface Pro or an iPad.
The regular Surface 3, the non-Pro Surface 3 is coming.
Yeah,
and
but I can
it's-
wait.
No, I mean, no one wants it, but the Surface Pro is just better.
Yep.
But if you want to save a lot of money, they got rid of that Windows RT bullshit. I think it's real Windows now. So like, if you
Ooh.
don't need the power of the Surface Pro, I guess we're gonna have to wait for reviews to come out. But the regular non-Pro Surface 3 might not be garbage.
Yeah.
Might,
I mean, honestly,
or it might be garbage.
Surface Pros and Surfaces in general, they're the only portable, non-just a tablet, like a not real computer I've seen in a long time that has the basically universal praise that used to be reserved for like Lenovo, like ThinkPad type things. Anyway, things of the day. This person has a bunny, like we have bunnies, like Neil deGrasse Tyson has bunnies, and he made the Game of Thrones throne out of carrots
Okay.
for the bunny.
And the bunny ate it.
And the bunny is just like, oh my gosh, and just sits there eating it. It's really funny.
It's a lot of carrot. Isn't the bunny gonna get full and sick?
Well, it looks like he made it out of a lot of carrot shavings down here. That's
You also
clever.
attach it to cardboard, which the bunny likes to eat.
Yeah, but they don't eat it, they bite it. So I just thought this was cute. Also, I had a better thing of the day that was this amazing World Star fight, but it disappeared from YouTube, and I didn't have time to find it
I'm
again.
sure it's on WorldStar.
I will find it, and it'll be my thing of the day in the future because there's something
And
special
I'm
about
pretty
this
sure
fight.
you can just go to WorldStar and click random.
Yeah, but this fight the way I would describe it was a combinatorial explosion of fighting.
Okay.
It was like this one guy starts fighting with this other guy, and there's people watching, and then someone starts going like, World Star, and this other guy's like, man, shut up, and then starts fighting with the guy who's yelling World Star.
Okay, I'm never shouting World Star.
Yeah. And it escalates from there.
Because if yesterday I had seen a fight, I may have yelled World Star. I pulled out my phone.
But the funny is the guy yelling World Star was videoing it, and then he got attacked, and the video is from someone else who was videoing it, and by the end of the video ends with that guy getting attacked. But I couldn't show that to you because it disappeared. So behold the Iron Throne out of carrots for my... I love how the video is called Built the Iron Throne out of carrots for my rabbit. Mm-hmm. I like titles of things like that.
Well, Rim.
Yeah?
Who you going to call when there's something strange in your bed?
My bed?
In your bed.
He drinks the piss.
An invisible man in your bed.
I can't believe Scott showed this to me.
Creepy ghost bed.
The whole time I'm watching it, I'm like, man, yeah, tub thumping like Neil Cicerega's thing. This is just like that Neil Cicerega thing. Oh my God. I had no idea. It was actually just, Neil Cicerega made this.
I thought, like Rim was saying, like, oh, this is just like Neil Cicerega's other thing. I thought you had seen what YouTube channel it was and thus knew that he made it.
But I did not, because I clicked on the link and just maximized immediately and started playing, and I wasn't sure what this was going to be until I learned about the man sleeping in my bed.
Well, this is bustin'.
Ghost bed.
Bustin'.
This has already replaced the original Ghostbusters theme in my head. I can't but hear this.
It is the original Ghostbusters theme.
This is, in fact, the original Ghostbusters theme now.
Sure.
In the meta moment, the book club book is still Watership Down. It is a story about rabbits, and while it has much allegory that can be read into it, the author himself has said that it's just a story about rabbits trying to find a new home. As we talked about at Anime Boston in our panel.
Mm-hmm.
Our next convention is Kineticon, which is in July, so we had long...
As much as that seems like it's a long way away, it's like 13 weeks away.
Yeah.
This weekend in New York City is the Mocha Festival.
Mocha Fest. We'll be there one of the days with a bunch of friends doing our thing.
It's in a new location. Don't go to the Armory. You will be lonely there.
Yep.
You'll maybe get shot there because it's an armory. I don't know if that'll happen. But, yeah, don't go to the wrong place. It's in a new place. Check their website to figure out where that place is. I think it's in Chelsea or some shit.
If you wanted to present at Kineticon, the submission deadline ended like a week ago, guys.
Fail.
So the form is still open, and you can still submit. However, I am just scheduling stuff on a daily basis right now.
You get negative points for being late.
Yeah, so submit your shit, guys. Kineticon is a rockin' con. If you've just joined us from Anime Boston, and somehow you listened all the way to this point, every night of Geeknights is different. So this is the Monday night, so it's technology and neckbeards and Linux and stuff. So you probably want the Wednesday Geeknights, which is actually anime and manga and comics and all that stuff.
Or maybe you're an awesome person who appreciates more than one thing in life.
Yeah.
You should listen to all 4 nights.
But if you go to our website, frontrecruit.com, I did post the list of all the anime we showed and talked about in that short-form anime panel.
Mm-hmm. We have a presence on the internet in every place that is on the internet. So you should go to your favorite, Facebooks, Twitters, our website, any place that there is things, and connect with us in a connecting way.
Yes, and also, if you did not yet press the button, do not fucking press the button. Wait for it, guys. Jesus.
Maybe it happened already. Go check.
No, it didn't. No, it didn't.
No?
Scott, I'm invested in this button. The button's fine.
I stopped paying attention.
Yeah, I wonder why you stopped paying attention. You filthy 60. I can't believe you pushed the button like that.
I didn't know what was going on.
I
just went to the website.
You had one shot.
I saw that there was a button, so I pressed it.
You had one shot,
And then
Scott.
I looked up what the button did afterwards, because I'm like, wow, I pressed that button, nothing happened. What the fuck?
I hope against hope that when the countdown timer hits 0, all that happens is that entire subreddit is deleted forever, immediately, and that's it. Nothing else. No word is ever said again.
Okay.
That would be the best possible ending. But my goal is to be one of the last human beings to press that button.
Okay.
So yeah, FPGAs, which I guess we've never talked about on Geeknights.
So FPGA is like a weird thing that only ridiculously technological people even know exist or care about.
So Scott, I learned about, like, at RIT, we had a class on the history of computing, and we talked about this shit a lot.
I knew sort of what they were, but I didn't fully learn about them until I was on a co-op that they had them, and I learned really super more what they were.
So I knew about them because I worked at IBM when I literally worked in the factory, like support like all the machines, like the computers on the factory floor that like did shit. That was my job. It was the factory that made the cell processor, which is in this class of this type of computing.
It's not an FPGA.
No, it's not. But a lot of the things I wanted, like CUDAs aren't really FPGAs either.
They're not even close.
Yeah, but they serve the same purpose.
Not really.
For my industry and for most people they do.
I mean, see, your problem is you're thinking about an FPGA from the perspective of, I have a job I want to get done.
Yes.
Right? And there are different things that do the job, but that's not, and some of them might be FPGAs and some of them might be not. But that's not what makes an FPGA special. The thing that makes an FPGA special is the fact that what it is and how it works is crazy, regardless of if it's actually useful or not.
And it's something that you'll think this is crazy. It's existed for a long time.
It's existed for a long time. So let me explain to you now. All right, so FPGA stands for Field Programmable Gate Array, which is complete gibberish, but it sounds kind of awesome.
It is a gate array that you can program in the field.
Right, so think about this. I buy a microchip. This microchip is way simple. It's like 4 AND gates lined up.
I had a bunch of those as a kid.
Right. It's like on the left side, there's 8 pins, and on the right side, there's 4 pins. It's just 4 AND gates all together. All right, it's 4 AND gates all together. I can't change it. It is what it is. And if I want to make a circuit board, I need to get more chips and connect them together on the circuit board and do all kinds of stuff, right, with wires in between these chips. If I want, say, a processor, like a CPU, I buy a CPU. Maybe I buy an 8086 CPU, or I buy, I don't know, a Core 2 Duo.
So that thing has a fucking million of these gates on it.
Sure, but it is what it is, right? An Intel CPU takes in Intel assembly instructions, executes them, and outputs what it's supposed to output. That's what it does. It does one thing, and you can program it. It can execute programs that are arbitrary in general, but it can only do that one thing. It is a one-job chip.
Now, at the same time, that job is generic because like an x86 chip is designed to be a generic processor. You can write code in C or C++ or Python or whatever, and it'll compile and work on that chip. If you throw a thread at a core on that chip, it'll execute.
Yep.
Don't have to worry like what kind of chip it is.
Right. So an FPGA is crazy. It's a chip, right, with a ton of freaking gates. Well, they're not really gates. They're basically logic blocks, right? And each logic block can be configured, right, to be sort of any kind of gate or even fancier than a gate in many cases. And all of these blocks are all connected to each other by a whole bunch of, we'll call them highways, simply because that's a good metaphor for it. So it's like, imagine if every house on the street could perform one logical operation, and you could change, any house could do any one logical operation, and you could connect the houses in any freaking way you wanted, and you could keep rearranging them willy-nilly all day long. And you could basically make any chip out of this chip.
So the idea
is a shape-shifting chip. It can take any form.
Yeah, so think about this. If you have an NES, it's hardware.
It has, there's some chip that's the NES CPU, and all it can be is an NES. If you have an FPGA, you could actually, if you had an FPGA big enough, you could program the FPGA to become the same chip that is in the NES, as long as it's digital. It can't do any analog business.
So think about that. If you want to run like an NES on your computer, you emulate it in software on top of a general purpose CPU.
And that works very well. There's
a lot of overhead. Like there's a reason why modern consoles are not emulatable easily.
Yes, that is true.
I mean, a lot of older consoles aren't even emulatable very easily.
You could, right? So basically the way an FPGA works is that when there's no power, it's blank. It's super blank. And if the power ever goes out, it erases. So fuck you. Don't let the power go out. And when it turns on, it actually takes a while to boot. It's not a quick booting thing. Like if you made a device based on FPGAs, every time you turned it on, unless you had some infinite battery life keeping that FPGA going, you would have to wait a little bit for it to get started. And what happens is there's one part of the FPGA that looks for some flash memory, external flash memory. Some of them now have internal flash memory, but usually external flash memory. You wouldn't use something slower than flash memory. That'd be a bad idea. And it looks in that flash memory for a program written in basically like some sort of HDL or VHDL language, which is not like any programming language you're used to, because it's not a series of instructions saying, do this, then do this, then do this. It's a series of instructions saying, you're a chip, become this shape. And then once the FPGA is done loading, it becomes the shape that was described by the program in the hardware definition language in the flash memory. And as long as it is powered on, it retains that shape.
So in practical terms, because I'm not a developer, so I come at this from this very, like, the other standard of like the view of what would you use this for? There are really only two uses for FPGAs.
There are quite a few uses.
Well, the core, I'm talking like at the highest level. Rapid prototyping.
Yes.
Of something that eventually you expect to print a real chip.
Right. So, like, let's say you're developing, I don't know,
battery controller, like a special integrated circuit.
Some sort of small microprocessor, but it's specialized. You don't want to use a general purpose microprocessor, even though that's probably a really good idea.
Yeah, well, like,
you want to make a special chip just for your hardware product.
Like, imagine you need a hard real-time system for something like very specialized.
Sure, but you're still working on it. So you just have an FPGA and you keep reprogramming it all the time until it's just right. And then once you have the FPGA programmed properly, you say, all right, let's make a chip exactly identical to this, the way I shaped this FPGA, and then you make a real chip. You can even do crazy stuff these days, like design chips, like in your chip layout program, like draw transistors and AND gates and everything all lined up, and then actually have that converted into the HDL to send to an FPGA, which is crazy.
The other application is if you have a use of computers that requires such low latency and such hard determinism or real-timeness, as in like real-time OS, the very specific and technical term. And if you're in one of those cases, like the best example I could come up with is financials, because that's where pretty much all this stuff gets used in the real world, is say you want to have a computer that's looking at the market, looking at market data, and sending orders to react to that market data. If you have an algorithm that requires an extreme low latency, you would want a chip that physically takes the market data and turns it into orders.
Yep, you could do that.
Yep, and that is the kind of thing that people use these for. Ultra high performance, highly specialized things, or rapid prototyping, or just QA testing of a special purpose device.
Right, now another thing FPGA, even if you need ridiculous low latency, right? You could just get like a modern CPU, like the craziest one you could buy, some Xeon nonsense.
You say that.
And write a program in assembly and get it to do the thing.
No, we found that there's this barrier under around 10 microseconds where soft real-time systems, like software running on an x86 chip, you just cannot have.
You can also do non-x86, but what the
FPGA
FPGA
doesn't buy anything.
What the FPGA is especially good at, that the regular CPU is not especially good at, is being parallel. You see, if you buy even the best Intel chip, was like an 8-core or 4 cores, faking 8 cores or whatever.
There are like some 30 upper cores.
Right, sure. If you get an FPGA, if it has enough gates in it, if it has enough logic blocks in it, usually FPGAs, especially the big ones, have way more input-output pins than any CPU is going to have, and have way more freaking gates total, because you're going to need them. But if you're doing something that doesn't take up the whole FPGA, you can sort of take that hardware definition language and just copy-paste like 5 or 6 times in a row, or maybe 100 times, or maybe 1,000 times. And that one FPGA will actually be 1,000 or 100 or a whole bunch of the chip that you need stacked up. And now each one of those is 100% independent of the other ones.
I have this
all
image.
Working in perfect parallel.
I have this image that I'm looking at. This from a presentation on FPGAs and Intel stuff and everything. And basically like a dedicated, like a regular Xeon. As you throw threads at it, you get more and more performance. But until Scott said, there's only so many cores you can put in one of those things. And once you hit that peak of threads, there is literally, like, you can't do more
Right. Even if you're doing some simple job like adding 1 and 1, you want to basically add 1 and 1 as many times as you can. Well, even the best CPU you can buy on Newegg can only simultaneously add 1 and 1 so many times at once. At some point, it's going to have to wait for one of the 1 plus 1s to finish adding up to 2 before it starts doing another one. With an FPGA, an adder doesn't take up many logic blocks. It probably takes up one of them, right? It's a really simple operation. So if you have an FPGA with like 1,000 freaking logic blocks in it, each one of them can add 1 and 1 simultaneously. And as long as you have enough output pins, you can output 2s on all of them simultaneously.
So this is
100% simultaneously. Not like there would be no waiting whatsoever for the next 2 1s to come in, for the next 2s to go out.
So this is why I brought up the cell processor, because the actual real world use for this, that massively parallel processing. The problem with using FPGAs to do that is that you can't just write like your code, like, oh yeah, I'll use like 800 threads or 1,000 threads or whatever, and just compile it and have it work on an FPGA. It's like there is a layer between that code, that logic, and the FPGA, and that layer is a developer who will charge you millions of dollars.
Yes, here's the problems with FPGAs. I mean, it seems like a miracle, right? Why wouldn't every chip just be an FPGA? I mean, throw out my Core 2, whatever it is, or i7, put an FPGA in my computer, and then I can just upgrade it. If they come out with a better CPU design, I'll just download it, upgrade my FPGA. It doesn't matter that it erases when the computer turns off.
You write your code?
I can flash that bit of flash memory with a new CPU design, and I'll never have to upgrade my FPGA or anything.
That's great until, one, anything ever changes.
Yep.
And then you have to rewrite all your code probably.
Yep.
Or two, if you make any mistakes writing your code.
Yeah. So
at all.
FPGA problem number 1, it is ridiculously difficult to program. You need to be a genius. I can't do it.
I know a few people who do write code for it, I can
do the tutorial simple, make the FPGA do math, but I can't
See, I look one high, you're looking at the level of FPGA at its core.
That's right, but that's the level you have to discuss it as, because in the real world, modern FPGAs are insane.
And they're all completely different.
They have memory now. They have analog things in them now. They got all sorts of crazy shit in them.
You'll get a PCI X card that just has these things on it, and you'll get this SDK and this documentation that'll basically tell you to code in a way that you have never coded before.
You need to be a genius to read it and understand it.
It's a lot like in Java. People were zero GC Java code. Because that makes Java as deterministic as non-Java. Garbage collection doesn't occur.
Yep.
But to write code like that is obtuse to say the least. And if you fuck anything up, all those gains are out the window.
Yep.
It's like that times a million with all the FPGA platforms. And vendors sell FPGA cards. They're all different. You have to be an expert in that implementation.
If you get just the documents explaining all the features of just one of these things, like the data file or whatever, that could be your whole job in life.
Yes. If you become an expert in one FPGA platform, you could get a job at a hedge fund.
And it doesn't help. Not only, right, are there multiple different FPGAs that are all really, really different. There's more than one vendor. There's 2 major vendors. And they both use different words to refer to everything. There's no standard terminology. So, if you learn, one vendor's FPGAs, you're going to be really confused if you suddenly have to work on one from the other vendor. It's going to be about a problem.
In practice, at least in my industry, and it's funny because the reason this came up is because I mentioned I'm on a panel in Mumbai on April 22nd called Low Latency Trading, What is Working and What is Not. And there are 4 topics we're discussing, and it's me and a bunch of managing direct, all these people.
Wouldn't the amount of money you had to pay someone to develop your FPGA stuff not be able to make up for the money that you earn?
I wonder what Rim's going to say on this panel. So,
and the time it takes to make it.
Here are the 4 topics.
Want to be obsolete by the time you're done developing the FPGA.
Here are the 4 topics on this panel. Let's see if you can pick out which ones Rim's got a lot to say about.
All right, all of them.
The use of fixed in low latency trading environments.
Yeah, that's what you do.
FPGA cards.
Yep.
The adoption of the fixed protocol in Indian markets.
and setting the clocks in India.
The need for the precision time protocol.
There you go.
Yeah. I'm going to shit all over PTP.
Anyway,
so
let me talk about all the other problems FPGAs have.
okay, then I'll talk about how this is actually done in the real world.
So, for another problem they have, they don't give a shit about power. They will just drain your fucking battery. Fuck you, right? It takes a lot of power to keep that going because
there are low power FPGA.
Yeah, that's still not as low power as regular dedicated processors.
Yeah, the problem is like even alternative solutions like using GPUs are not low power either.
No, but I mean, in addition to the power that it takes to actually, do the processing and run the clocks or whatever you got going on with the FPGA, you also have extra power going in to sort of keep it in the shape that you want it to be in. As soon as the power is cut, all those transistors just go clunk back to zero.
Now, that kind of problem has mostly been dealt with over the years the same way that hard drives do. Like, hard drives, unless you have a shit server, have got some form of write caching, meaning writes are coming into the disk, and the thing between your program and the disk tells the program, yeah, I got it, but it's not actually on the disk yet. It's in a buffer somewhere.
Sure.
And they either have capacitors or they're caching it to flash. They're doing things to persist that data.
Yep.
That's a solved problem.
Right. Also, FPGAs, right? So let's consider this scenario, right? We take an FPGA, and FPGAs are fast. It's a hardware device. It's ridiculously fast, hardware speed.
Yeah.
But if I program an FPGA to do the same thing as a 486, unless it's some crazy big FPGA, it's still probably going to be slower at that than a 486 would be.
Yep, so you have to solve a very constrained problem with an FPGA.
But if I put two 486s in one FPGA, now daddy's cooking.
So think of this, like an FPGA to do everything that my computer from 1996 does would be a nightmare to write. But an FPGA that encodes H.264 video, that would be so much better than a general purpose processor that you wouldn't believe it.
Yep.
Orders of magnitude faster.
Now, we already talked about how expensive it is to get someone to write, to configure and program FPGAs.
The fucking chips aren't cheap either.
Right. The chips are also ridiculous expensive. Now,
we have some at work, but they're not real FPGAs. They're basically this company called SolarFlare. They're network cards that have sort of
an excellent use of FPGAs.
Yes, hardware program. So say I'm doing a packet capture, right? I can have the filtering happen in the hardware.
Yep.
That is crazy and awesome. I could have reactive loops. I could have the card have code where if certain kinds of data come in, data comes back out without even hitting my buses.
Yep.
Like, that's the kind of shit you can do.
Right.
But that's not just an FPGA. That is a specific, it's like one layer above that. It's using similar types of technology or solving similar problems, but you're another layer abstracted. Like, it solves network-related, massively parallel or high-performance problems.
Right. But yeah, they're really expensive. They're not, if you get the big fancy ones, they could be a lot of money. But even cheap ones, right, small ones, there's still more money that, like, if you take an FPGA and you program it to do something simple, and then you want to put that in an actual product, you're just pissing away money. You were better off buying a chip that was already equivalent to whatever you made that FPGA do.
So here, a recent SolarFlare. So SolarFlare Flareon, the 7 series card.
Yep.
This is just a network card. I can buy one on Amazon for $1,000.
Yeah, that's
your
one.
Your network card on your server costs $0 because that comes with your motherboard.
Built into the motherboard.
Yeah.
And in the days when we bought them, they were $5.
Yes.
And that was
this card it's a $1,000 network card. So if you design software that needs this SolarFlare card, everyone who buys your software also has to buy a $1,000 network card.
Yeah. So talk about networking. Right? Networking is a thing that's really easy to do in parallel, right? You have a whole lot of Ethernet cables coming in to a switch or something.
And you got a whole bunch of packets.
There's a whole lot of packets.
That need to be muxed and demuxed to applications. It's like the perfect storm.
Yep.
The FPGA or the specialized hardware can, like, split incoming TCP packets.
Inside of one fancy FPGA, you can basically put, like, hundreds of little chips that in hardware each can process TCP IP packets all the way from the Ethernet all the way up to that level. And so this chip is basically doing all that work in hardware at ridiculously high speed, and it only passes on the packets to the computer that you need. You could have like 100 gigabit Ethernet cards plugged into your computer with this one FPGA just taking care of everything.
Now, I think, just from my like professional perspective, like the work I do and just my life as a technologist, I don't think FPGAs are useful for very many things.
No.
Because there are things they are super useful for, but high performance computing, I think that is a dead end.
Yeah, I mean, in these days, you're probably better off just getting a whole bunch of regular CPUs for the parallelism.
Or you
need to have a very, very specific or limited use case to need an FPGA. Certain industries, certain kinds of devices, they still need them. It's not like we should stop making them, but
like even in my industry, right? Like in software with Java, we're down to like sub 20 microsecond processing times for these things.
Right.
Things we're talking about. A well-programmed FPGA could probably do that similar task down to about, at best, like 8 to 10.
Mm-hmm.
If 10 microseconds matters that much, like how much are you willing to pay to save 10 microseconds?
Yeah. And are you ready? What happens when it messes up? The power
what happens
goes out.
if anything changes in the market and you have to do something differently?
Yep.
You got to hire that $1 million developer again.
Mm-hmm. There's not too many people out there who can do something that complicated, right? It's like programming it to be an Ethernet card is already pretty complex. Programming to do anything fancier is really hard.
So, in my opinion, the real way to do this kind of thing, because the problem most people are solving is some massively parallel problem, like video encoding.
And it has to be something digital, right? If it's usually has high input output. High input output, that's what all the pins are for, right? Or so it has to be purely digital. You can't be doing any like analog processing on there. What you can do though is you can get a whole bunch of ADCs, stack those up next to an FPGA, and then the FPGA can do a bunch of work on the
ADCs are the worst things in the world.
No, they're not. I'm not saying that.
No, I'm saying in terms of welcome to heat and power.
Sure. But like, let's say you have, I don't know, radio signals coming in from like 1,000 antennas.
Yep.
So you have an ADC on each one, and you could have like one FPGA processing all those radio signals in parallel, and then outputting it to a bunch of storage devices really quickly.
So in practice,
but you could just do that with less work would be to just stack up a whole bunch of regular old CPUs, one per antenna.
it comes down to, like, do you need some sort of hardware advantage? Do you need a hard real-time solution? Do you have some very specific constraint? Most of the time you don't, or you do, but the money it would take to actually meet that constraint obviates the need.
Mm-hmm.
So in practice, honestly, use a framework that is easier to code in, that is also massively parallel, like NVIDIA's CUDA stuff.
Yep.
I mean, if you Scott, could write code that would take advantage of CUDA.
Yes, anyone who
easier.
can code can do that.
Yes, and like right now, like
in fact, I have done so.
And that stuff is already used. CUDA cores, like CUDA processing, is used in a lot of practical applications that are not like ridiculous finance, like billion-dollar solutions. And there's a new thing on the horizon that I didn't know a lot about, but I've been learning a lot about it lately, partly because I'm talking on that panel. But Intel, this is what's going to replace FPGA, I think. Intel has their Xeon Phi coprocessor. The vague idea is that these new Xeon chips and the boards that support them will have normal Xeon cores, and then they have these like vector cores that do this shit. And the important part is not the hardware. The hardware is amazing in all these kinds of things. Like when people who are experts at this try to explain to me like the cache concurrency problems they deal with and like what kinds of buffers are used and like how like physically how the chips are laid out and how you should allocate memory in your applications to match that, I'm not smart enough to understand that stuff. But as a result, the hardware is not the interesting solution. The interesting solution is the software support to allow normal developers to use this shit. So Intel is a company, I think, that has the resources to provide the tools.
That's many people who work at Intel are at the FPGA programming genius level.
Yes, but you can't use those solutions relying only on people like that. You need a layer in between. I mean, how many people still write assembly? Like, that happens.
Not many.
There are uses for that, but most of the work in the world gets done at least a couple of layers above assembly.
Yep.
So Intel's Phi framework, PHI, been learning a lot about it, and basically it looks like that. This is, as best I can tell, like, these things will take threads. Like, you can just write C code. Like, you don't need to worry a lot about what's going underneath. You just have to worry about...
If you believe they're advertising.
Yeah, well, this is more than just advertising. I have a pretty thick slide deck here of a class. This was a class on how to write the code.
I should make a thick slide deck.
You want to see this shit? Like, this goes way beyond the level I can really understand without
I'll just make a crazy slide deck and everyone will believe it.
Maybe. But this is like a crash course I'm looking at on how to write code for these things. And this looks way more doable. And the other reason I think this is interesting, that is Intel has the ability to make these things just exist on everyone's computers. If these coprocessors are just kind of standard on high-end servers, you can write code that assumes they're there. You can't do that with just FPGAs.
So yeah, an FPGA is a thing. It's useful in the world in many places, but for most people, it's never useful. And it's just mostly the thing about them is that, like, the fact that they exist is like some like miraculous, amazing thing. It's like it's a chip that you can program to become any chip, which then itself can be programmed if you want it to be.
Oh my God, it just runs Linux. Okay, I got to read a lot more about this before I talk about it in depth on the show, but...
Yeah, if the concept that an FPGA is a chip that can become other chips fascinates you, just go on YouTube. There's like a bunch of videos all about this that will be incomprehensible, but will make you go, whoa, that's crazy, yo.
But if you want to get a job, unless you're doing integrated circuits for like hardware product applications, either look at this Intel stuff or get really good at NVIDIA's CUDA stuff, because that is actual, practical, useful money-making skill.
Well, I mean, if you learn FPGAs, you can also make a lot of money if you're learning VHDL or something, but the places you can work are only places that are actually using those things.
You're going to work at like a battery company. You're going to work at a hedge fund.
There are places that you can work if you learn it. And
you work at the NSA, like doing signal processing.
Yeah, who knows what you're going to do. But for most people in the real world, you will never need them, and rarely will they be the correct optimal choice for anything.
Look at these other things, because there's a more general application to these other things like CUDA.
Yeah. If FPGAs were really the awesomest, we would already... It's like... There's not some weird reason we don't all have them in our computers.
Yeah. Well, kind of like, remember, like RISC systems versus CISC systems, or like Token Ring was deterministic.
Whoa.
And Token Ring is gone now, even though it was better in a lot of ways than Ethernet. I wonder why that is.
Betamax is gone now, even though it's better in a lot of ways than VHS.
This has been Geeknights with Rim and Scott. Special thanks to DJ Pretzel for the opening music, Kat Lee for web design, and Brando K for the logos.
Be sure to visit our website at frontrowcrew.com for show notes, discussion, news, and more.
Remember, Geeknights is not one, but 4 different shows. Sci-Tech Mondays, Gaming Tuesdays, Anime Comic Wednesdays, and Indiscriminate Thursdays.
Geeknights is distributed under a Creative Commons Attribution 3.0 license. Geeknights is recorded live with no studio and no audience. But unlike those other late shows, it's actually recorded at night.
It's Monday, April 6th, 2015. I'm Rim.
I'm Scott.
And this is Geeknights. Tonight, FPGAs and all those related things.
Let's do this.
Been a while since we've done a Monday show. It's just the weeks we kept missing happened to be weeks where we'd come back on a Tuesday, Thursday.
That's generally how things work. If you go away on a weekend, Monday's a bad day.
Yep.
Also, Monday's the day with the least ideas.
Well,
so we're the most likely to bail on it.
We came up with this idea on the last show.
Sure.
And thank the gods, convention season is done for us until July with Kineticon.
Yeah, I mean, usually convention season is summer. Usually, right? That's
Well,
when the biggest.
you know, we always say usually. It was usually for us like 5 years ago.
But I'm saying conventions originally, historically, were all mostly in the summer, and the big ones still are. The Gen Cons, the San Diego Comic Cons, whatever.
Yep. But the big summer cons that we used to go to, we stopped going to.
Conventions are supposed to be in the summer. That's when kids aren't in school, so they can go.
Wait a minute. By that logic,
they can go.
By that logic, I only want conventions that are during school.
Sure. But I'm just saying, if you're the convention runner, you want to get the most people to come. They're usually in summer. But all the other conventions, the ones we go to mostly, had to abandon summer to get away from the mega conventions that were in the summer, taking up all the peoples. So we end up going to like a bunch of spring conventions and winter conventions.
Yep.
Like PAX Prime is the very end of summer. PAX East is like in anime also like the beginning of spring.
And then what made it worse?
They got pushed to the edge
always bike
to damage my body.
I
and
always
suffer
bike
in
hard.
pain.
See, I don't bike to damage levels. I bike to hard levels. I bike to how fast can I go without getting to the point where I cannot breathe fast enough to replenish oxygen.
I do not exert myself. I exert myself to the point at which, if I exerted any more, I would feel uncomfortable. I do not feel uncomfortable at any time.
Do you
whatsoever.
still want to do that race? I don't think we should race.
What kind of race?
We were talking last year. We would do a race where we both leave at the same time. First one to the Sand and Rockaway.
Sure.
Take any route you want.
Sure.
You want to race? You want to do it?
Yeah, why not?
We should both GoPro it, giving commentary the whole way.
So this is the shortcut I'm taking, and I'm moseying along. Meanwhile, Rim pushed himself way hard, and he's on the bridge, and he's dying.
Dying? You mean winning?
And here's me catching up to Rim on the bridge, just sort of moseying, and I'm behind him, and I pushed him off the bridge. Now he can't win.
The thing is, we would not be on the bridge at the same time. You wouldn't be able to push me off.
Uh-huh.
My main strategy when there's danger is to run away faster than whoever it is who's trying to hurt me.
Mm-hmm. Well, good. I'll just stay right behind you until you pass out, and then go to the beach.
Yeah, unlike my man Mitasuji, I think I can power through to the end.
That's what Mitasuji thought too.
Yeah, but he wasn't as powerful as I am, apparently.
Sure, okay.
So you got any news on this Tech Monday? Back from Anime Boston? Back from ZenkaiCon?
It's
back from PAX
sort
and PAX
of
and
a
PAX?
news. I don't know. It might actually be an old thing that was just recently, again, re-brought up on the internet. Or it might be new. I can't tell. But it's just kind of cool. Estonia, a country on the other side of the world. I'm sure this country has problems. I'm actually going to be honest and say I don't know a whole lot about Estonia. I know it's in Eastern Europe.
It is perhaps a member of the Baltic states, along with Latvia and Lithuania.
Edges of the summer.
Because there are 4 PAXs, and they're in different parts of the country or the world, they end up, they can be clustered way outside of the norm of, the convention circuit in the Northeast.
But this is fine by me, because it means I don't have to do anything in summer except enjoy summer. I don't have, to abandon some awesome summer weekend to go stay in a giant building somewhere.
But yeah, I'll keep it short because it's not going to turn into the biking show. But today was the first day of the season. I biked to work.
Still too cold.
What the fuck? It's like 60 degrees.
Yeah, which means when you bike, it's like 45 degrees.
Scott, you're a little baby. I don't even know what to say
All right,
anymore.
I'm going
about
to shave
this.
your head, and then I'm going to send you biking.
Wear a hat. You got to wear a helmet anyway.
A hat is not good.
I mean, I biked to work today, and
there's no happy medium. Either your head is melting because you put a hat
Scott,
on.
my hat is not the factor. I was wearing shorts and a t-shirt. In fact, I was wearing a button shirt that I got hot and I unbuttoned.
Did the bridge not blow a mighty wind across you?
It did, but you know what? I was biking so hard, I was still hot.
Why are you biking so hard? Just
I
to
always
go to
bike.
work?
Scott, so this is what's awesome. I biked to work and back today, and I used Strava. Running hard all winter really paid off. My time not only didn't go down significantly over the winter, but my first commute home from work took 30 minutes. And historically, my best time ever was 26 minutes.
My commute is about 30 minutes.
My commute's 6.8 miles.
Mine's 5 miles.
Yeah, 5 miles? Really?
Yeah.
It takes you... Oh, I guess you got that Astoria stuff.
Mm-hmm.
So can you do 6.8 miles in 26 minutes?
I don't bike hard. I just sort of mosey, and it takes me 30 minutes to do 5 miles. So
Yeah.
I don't know how fast I would go as if I was trying.
Lithuania?
Yes, that is about all I know. But I know one more thing about Estonia now.
Super techie.
The whole Eastern Europe is pretty techie,
But
right?
Estonia
in a different way than we are.
particular and above other states is particularly techie at the government level.
Sure.
And has been for a long time.
So one thing Estonia offers, and it sounds awesome when you hear what it is, which it's less awesome in reality, is e-residency. So at first you're thinking, holy shit, I could be an Estonia resident, but digitally and not have to go there. And that is sort of true. But it's not as awesome as you would think.
But at the same time,
I mean, most punk kids out there, if they're like me when we were in our like Sealand thinking days,
Yep.
they're thinking, gonna renounce my U.S. citizenship. I'll be an Estonia e-resident. I'll live on the internet. Sovereign citizen, can't fuck with me. Right?
Yeah.
That's what the punk kids are thinking right now. But sorry, punk kids, that's not what this is.
see, sadly though, I knew the thing that this was because I already knew about this from Estonia, but because of what they're calling it, it's not entirely obvious that it's the same thing right away.
Right. So what this is you become an Estonia e-resident, you apply, and they give you like a card, and the card has some, digital keys in it, for, secure signatures, private public key deal. And you can use that card with those keys to legally sign documents like contracts in Estonia. So this is ridiculously useful if you want to conduct business in Estonia. Like, I'm a U.S. citizen, but I want to open up an Estonian business or open up a web store that sells things to Estonia or any sort of Estonian business deal. Maybe I got to
Now,
sign.
meanwhile, look at the U.S. You either scribble some ink on a dead tree,
Yep.
or you try to use PGP signatures that no one can figure out,
Mm-hmm.
or you have to use 100% Adobe workflow, and even then, it's not the same level of cryptographic trust.
No, not really. It's also trust Adobe and the government, right?
Yeah.
But yeah, if you want to do business in Estonia, you can get one of these things. And it's really freaking useful and cool and modern. And I don't know why every country doesn't have this.
Dude, the U.S.
Because
should have
every
been
country is not Estonia.
This should have appeared in the U.S. they're in the 90s.
But they banned exporting this encryption in the 90s. That's why
Because
they
it was
wouldn't
a weapon.
Sure.
Yeah.
Yeah.
The Zimmerman stuff.
Right.
Yeah, I mean, I've said this for easily 20 years now. The U.S., when you're born, instead of getting a piece of paper with a stamp printed
You shouldn't need
a
a birth certificate, a driver's license, a social security card. You shouldn't need all these fucking
Well,
cards.
I'm specifically Social Security.
Yeah, one government card, one key on there. That should do every single thing there is to do.
Every citizen, when they're born, should be given a private key. And basically, it's a thing that you can use to cryptographically, not for hiding things, not for encrypting things, but cryptographic signing. So
Yep.
you can prove who you are and you can prove if you did something or not in an official capacity.
Yep. It just needs two factors. One, the card itself with the keys, but the
Yep.
keys are encrypted. So the second factor is the password to decrypt the key to do the signing.
This technology
Just like
has existed
SSH.
since the 80s. And the fact that other than in Estonia, it is not in common use for the things that it is best
For every
at.
human being on Earth?
Yeah, it's this solves
Guess what? There's plenty more keys than there will ever be human beings to ever exist.
this technology solves a ridiculous number of the real world problems that people in the industrialized world have been facing for 100 years.